Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0793, indicates an issue with the intermediate shaft speed sensor A when it fails to send a signal. This error pertains to the continuously variable transmission, CVT, of your Honda HR-V, manufactured between 2016 and 2022. The intermediate shaft speed sensor plays a crucial role in monitoring the speed of the transmission components, providing critical data to the Powertrain Control Module, PCM. For optimal performance, when the sensor circuit fails, the PCM is unable to receive the necessary signals to manage the engine and transmission efficiency effectively, leading to potential performance issues. Before beginning any troubleshooting, it's essential to review the general troubleshooting information, as this DTC typically arises from electrical problems rather than mechanical failures within the transmission unit. The DTC P0793 relates specifically to the intermediate shaft speed sensor A, which is located within the CVT assembly. This sensor is responsible for detecting the rotational speed of the intermediate shaft, relaying this information to the Powertrain Control Module, PCM. The PCM analyzes this data to ensure effective performance of the transmission by adjusting gear ratios and other factors to optimize fuel efficiency and driving experience. As part of the diagnostic process, it's crucial to establish whether the DTC is confirmed, pending, or part of the freeze frame data. This helps in identifying the conditions under which the fault occurred, thus guiding further investigations. In case the error persists, it may indicate wiring issues or faults in the sensor itself, leading to the activation of this specific DTC. The main cause of DTC P0793 is attributed to an electrical circuit problem. This can arise from various factors, including damaged or disconnected wiring that prevents proper communication between the intermediate shaft speed sensor and the PCM. Wiring issues may involve open circuits or shorts that compromise signal transmission. Another potential cause is a faulty intermediate shaft speed sensor itself, which might be internally damaged or contaminated, leading to a lack of signal output. It's essential to note that while mechanical issues within the transmission may lead to performance problems, they do not activate this particular DTC. Understanding these possible causes is vital for effective troubleshooting and ensures that technicians focus their efforts on the actual sources of the issue. When DTC P0793 is active, several symptoms may manifest, indicating possible issues with the transmission system. One of the most common signs experienced by drivers is poor transmission performance, which may present as hesitation, slipping of gears, or delayed engagement, particularly when the vehicle shifts between speeds. Additionally, the vehicle's dashboard may also display a DTC indicator light, alerting the driver to a malfunction within the vehicle's system. In some cases, there may also be abnormal noise or vibrations felt during vehicle operation. Identifying these symptoms early can prevent further damage, as continuous driving under these conditions can lead to more significant failures in the transmission system. Regularly monitoring vehicle performance can help in catching such issues before they escalate. The first step in troubleshooting DTC P0793 involves verifying the issue by putting the vehicle in the on mode, which powers the vehicle's electrical systems without starting the engine. This allows the technician to access diagnostic tools and clear existing DTCs using the Honda Diagnostic System, HDS. After clearing the code, it's essential to turn the vehicle off and safely lift it so that the wheels can rotate freely. Once the vehicle is in the correct state, the engine should be started while disabling the Vehicle Stability Assist (VSA) feature to ensure that the transmission runs without interference. Following this, a test drive should be performed with the shift lever in the D position, maintaining speeds over 19 miles per hour, 30 kilometers per hour, for at least 30 seconds. Subsequent checks via the HDS will help in determining if the DTC remains confirmed, indicating that a legitimate issue exists that requires further troubleshooting. In this step, the vehicle must be turned to the off-lock mode to ensure safety while disconnecting components. The next action involves removing the 3P connector from the CVT drive pulley speed sensor, isolating it from the system to perform checks without interference. Following this disconnection, the vehicle should then be switched back to the on mode, allowing for voltage measurements to be taken. At this stage, the technician will measure the voltage between specified test points, specifically between the sensor's connector number 1 and the body ground. The objective is to determine whether there is an approximate voltage of 5 volts present. If this voltage is detected, it indicates that the supply voltage to the sensor circuit is intact, prompting the technician to proceed to the next step. However, if the voltage is absent, further investigation into the wiring and connections must take place. During the third troubleshooting step, you'll continue to troubleshoot the VCC1 line, which is vital for supplying voltage to the CVT drive pulley speed sensor. With the vehicle still in the on mode and the sensor connector disconnected, measurements should be taken between test points number 3 and body ground. An observation of an expected voltage of approximately 5 volts indicates that the VCC1 wire is functioning correctly, and it directs the technician to the next step. However, if the correct voltage level is not reached, it suggests there's an open circuit in the VCC1 wire, leading back to the PCM. Identifying and repairing any interruptions in this wire is crucial to restoring proper signal flow from the sensor to the PCM. The integrity of the wiring and connections in this part of the circuit must be analyzed thoroughly to pinpoint potential issues. In this step, the technician will conduct a voltage check on the CVT drive pulley speed sensor to confirm its operational status. With the sensor connector still disconnected and with the vehicle in the on mode, measurements should be taken between test points number 2 and number 3. A correct voltage reading of approximately 5 volts indicates proper function of the sensor wiring, but suggests that the sensor itself needs examination. If the sensor is found to be damaged or contaminated, it will need to be visually inspected to identify any physical issues, such as debris or internal faults affecting its performance. Depending on the findings, the technician may either repair the issue by cleaning or replacing damaged parts, or if the sensor is in fact functioning correctly, they would move on to inspect the wiring further up the circuit for issues. As you move into troubleshooting step 5, the vehicle should first be turned off again to ensure safety during the diagnostic process. The technician will utilize the HDS system to jump the SCS line, while the necessary connectors, including the PCM connector B51P, are disconnected. This will facilitate accurate continuity checks between the CVT drive pulley speed sensor connector number 1 and ground. A successful continuity test indicates there's a shorting issue within the NDR wire between the sensor and the PCM that will need immediate repair. If continuity is not present, it confirms that there are no shorts and allows the technician to move on to the next step in the diagnostic process, focusing on potential open circuits instead. The 6th step focuses on performing a continuity check between the CVT drive pulley speed sensor connector number 1 and the PCM connector B51P number 44, confirming the integrity of the NDR wire. With the vehicle still in the off, lock state, and the connectors disconnected, a successful test will indicate that the NDR wire path is clear, suggesting that there are no open circuits in this segment. In the event of a clear wire pathway, the technician then should check the PCM to ensure it has the latest software updates installed. If updates are necessary, applying them may resolve the issue and eliminate the DTC P0793. If updating does not resolve the issue, or if the DTC persists, substituting the original PCM with a known good unit would be the next approach to ascertain whether the original PCM was faulty. If the DTC clears after substitution, it confirms the need for a PCM replacement. After completing the necessary repairs associated with DTC P0793, it is crucial to perform a final verification of the system to ensure everything is functioning properly. This begins with using the HDS to clear the DTC, resetting the system to eliminate any historical fault codes that could interfere with diagnostic assessments. Once cleared, the vehicle should be test-driven under different conditions to check for any reoccurrence of the DTC. During this test drive, it is essential to monitor the shifting behavior and overall performance of the CVT to confirm that the issue has been resolved. After driving, the technician should check the HDS once more for any new DTCs or pending fault codes. If all systems are operating normally and the DTC does not return, the repair process can be considered complete. To prevent the recurrence of issues related to DTC P0793, a proactive approach to preventive maintenance is vital. Establishing a regular inspection schedule for the vehicle is key. This should include checks on wiring and electrical connectors to identify any signs of wear, damage, or corrosion early on. Such inspections can help prevent the occurrence of electrical faults that might lead to breakdowns or DTC activations. Additionally, keeping the vehicle's software updated ensures that the PCM can effectively interpret sensor data and manage transmission operations without interference. Furthermore, if the vehicle is subjected to extreme conditions regularly, increased frequency in these inspections may be warranted to ensure reliable performance. Following disciplined preventive practices can contribute significantly to the vehicle's longevity and enhance driver experience. In conclusion, addressing DTC P0793 effectively centers around understanding that the root causes oftentimes lie within electrical circuit issues rather than mechanical failures. Throughout the troubleshooting process, clear testing protocols are essential for pinpointing faults with the intermediate shaft speed sensor and associated wiring. Maintaining a keen awareness of symptom presentation can assist technicians in tackling issues promptly before they escalate. Moreover, regular maintenance and timely software updates strengthen the vehicle's performance and reduce the likelihood of future DTC activations. Overall, a structured approach to diagnostics and prevention ensures a smoother driving experience with the Honda HR-V, safeguarding both vehicle performance and driver safety. Please like and subscribe to the channel. See you next time.